Today's lesson is section 3.7, day 1, and it covers a very important topic in AP Calculus, which is implicit differentiation. There is always a question on this on the AP test, and it's usually in the free response part of the test. All right, so what are implicit functions versus explicit functions? When I was sitting in your shoes just a couple years ago in college and trying to understand my calculus classes, no one ever told me the difference between explicit and implicit functions. So I never really understood it, but I did it. So hopefully you might have a better understanding than I did at the time. An explicit form of a function is where you have the function listed by a y equals or an f of x equals, either one, but you know exactly what the function is with respect to x or whatever variable you're using, but it's very well laid out. An implicit form of a function is when you have x and y's on the same side of the equation multiplied together, and therefore you don't always know exactly what y is. Now in this example right here, you can just solve for y, right? Divide both sides by x, y equals 1 of x. Okay, we have the function, now we could take the derivative of that. So our problem's solved, right? Well, sort of. For that equation it's solved, but what about for an equation like this? How do we take derivatives of this? We can't really isolate y on one side of the equation. So that is where implicit differentiation comes in. Okay, and this is where it is needed. A couple things about implicit differentiation. Always remember we're differentiating with respect to x. When x terms are alone, you just differentiate as usual. But when you're differentiating terms involving y, you have to apply the chain rule because y is a function. And we assume that it is defined implicitly. So we are going to take the derivative whenever we have a y in equation. We're going to take the derivative of that y and then multiply times the derivative of the dy dx, because we don't really know what this y function is. So you'll see a lot of dy dx's, and we'll use this notation for derivatives of y in this section and in implicit differentiation throughout our discussion of it. All right, lots of examples to show you how. First equation, and this one we probably could isolate and take the derivative without doing implicit, but for example's sake, to keep it easy to start out with, we're going to do this implicitly. So we look at the left side of the equation. We're going to take the derivative of the y. So y is actually our inside function. We have to use the chain rule over here. Okay, so chain rule is in effect. Chain rule with the y is 3y to the squared. We're taking the power chain rule. And then we multiply this times the derivative of the inside. We don't actually know an exact derivative for the inside, but we know the derivative of a y is dy dx. That is the derivative of the left-hand side. The derivative of the right-hand side is 3. Okay? Now, what we usually do with these functions is we isolate dy dx. So we are going to divide both sides by 3y squared. All right, and that isolates our dy dx. I'll actually give you a few steps. I think this is 1 over y squared when we simplify it. I'll actually give you some steps for implicit differentiation. Let's do a couple more. Oh, no, I'm giving you the steps right now. Here they are. Differentiate both sides, collect dy dx, factor out dy dx, and solve for dy dx. So that is what we just did, and that's what you will do. All right, more examples. 4y, the way we take the derivative of 4y is, the derivative of 4y is 4, correct? And then the derivative of the y is just dy dx. All right? So y is considered to be a function in this case, and we take the derivative of the 4y, which is 4, and multiply times dy dx. Derivative of x squared is just 2x. Ooh, here's a good one. The derivative of cosine, remember the derivative of cosine is negative sine. We keep the angle the same, and then we multiply times the derivative of the inside angle, which is dy dx. This right here would become a positive. Okay, so in accordance with our rules that we just had, we want to get all the dy dx's on one side of the equation. So we're going to subtract this term, sine of y dy dx, on both sides of the equation. Negative sine of y dy dx. All right, so that leaves us on the right-hand side with just a 2x. On the left-hand side, we have 4 minus sine of y times dy dx. So we're going to collect both of these terms that are multiplied by dy dx, put them in a little parenthesis, and multiply them. So in order to get dy dx by itself, we divide both sides of the equation by this, 4 minus sine of y. That cancels out over here, leaving dy dx alone, and our final answer, therefore, is this. Notice that if we're ever asked to evaluate this at a point, we need an x, y value. Okay, another example. This lesson is almost all examples. So derivative of x squared is 2x. Derivative of negative 2 is just a constant. I'm going to multiply that by 3y squared, and then don't forget dy dx. Okay, all of that is multiplied together. Plus, we just did this one, 4 dy dx. And the derivative of 2, here's where people make a lot of mistakes. The derivative of 2 is 0. It is not something else. All right, we're going to combine these two terms together because they both have dy dx's. First, let's subtract 2x from both sides to get that over to the right. So we have equals minus 2x on the right. And let's combine these two terms here. So we have minus 6y squared plus 4 times dy dx. And that equals negative 2 x's. Now we divide both sides by this. And voila, we have our answer. All right, this is combining again. Just one more example. I don't know if this is the last one, I forget. Negative 3 times dy dx. All right, we're going to get good at this because we're going to practice it. This is 10x. And the derivative of sine is just a plain old cosine of y, but we always have to use the chain rule and multiply by dy dx. All right, to simplify this, we want to get dy dx by itself. So subtract this cosine of y term. From both sides. We're going to group the negative 3 and the negative cosine of y together. These cancel out. We're left on the right-hand side with just a 10x. And last step, we divide by the negative 3. This is not cozy. This is cosine of y. All right, that is that example. All right, we're going to skip example D and then go to this example right here, finding the equation of the tangent line for the implicit function. We have a point. What we need to solve for is m, which is going to be dy dx in this case. So we're looking for some number at x equals square root of 2 over 2, which would be our slope. So we're going to have to solve this equation and take the derivative of it. So let's distribute first. X squared times x squared is x to the 4th plus x squared y squared equals y squared. All right, in taking this derivative, we have one more challenge to overcome, and that is this term right here. I could make a smiley face out of that. But anyway, this term is a product. We have to use the product rule. All right, so don't forget to consider that when we do that. Let's start by making u equal to x squared and v equal to y squared. Then we have our derivative of u, we know is 2x. Our implicit derivative of y squared is 2y times dy dx. All right, so that's just to do the derivative of that x squared, y squared term. So let's put this all together right now. The derivative of x to the 4th is 4x to the 3rd. All right, let's use the product rule on x squared, y squared. We're going to multiply u times v prime, which is plus 2x squared y times dy dx. And then we'll multiply the other two, 2xy squared. And then we're going to take the derivative of the right-hand side of the equal sign, which is 2y dy dx. Next, our challenge is to isolate the dy's on one side of the equation. So this term right here has a dy dx on it, and this term has a dy dx. So let's take this one and move it to the right. I think that'll be easier. I'm into the easiest method here. So subtract that and subtract that over here. All right, so this goes away from our left-hand side. Rewriting this equation one more time, 4x cubed plus 2xy squared equals, let's factor out our 2, actually let's put the dy dx first. It doesn't matter which one because it's multiplication, but 2y minus 2x squared y. Now you need to be really careful with your x squareds and your y squareds that you don't mix them up or lose an exponent somewhere. So continuing to get dy dx, we're going to divide both sides by the 2y term. Okay, divide by the same thing. And this cancels out. All right, this is our derivative. Now what we need to do is plug in, remember the square root of 2 over 2, square root of 2 over 2, plug that into this equation and figure out what our slope is. This is a very nice algebra problem too. See how well you can square square roots. This is a minus. And you can check my work because I know you like to do that. This is our slope, this is our dy dx. But the amount we get for the slope should be 3. All right, so now we have an equation we can write. I think the problem was to write the equation of the tangent line.
Miss Gabby.
And that is the equation of our tangent line once we found our slope is 3. And that is the end of our lesson for section 3.7, day 1.